So this is just a quick video to respond to a couple of questions that you sent me in an email. I could have responded to them by email, but since it would have involved looking at code, I figured it'd just be quicker to address them through just through another video. So one of the first things you asked me was you pointed out that you were still unclear about what is considered gunship code versus user code. I mean, the easiest way to see the difference is if you open up the Visual Studio solution, and you go to the Solution Explorer, and you collapse everything, you'll see that there are a couple of projects here. The two projects that have code are libgunship and spectacle. Libgunship has all of the engine code, and if you open that up, you'll see all of the engine-specific things. So here in the source files, you see stuff like engine.cpp, scene.cpp. Spectacle is all of the user-defined code. So if we open that up, we'll see things like the level manager system and the create destroy system. You had asked whether or not level manager system is engine code or user code. It's user code. The only engine systems that I have right now is the alarm system, I believe. If we open this up and we go to our header files and go to systems, yeah, we'll see that the alarm system is the only thing, and all the alarm system does is tick the alarms every frame. Once I start working on the collision code, there will be a collision system that's running every frame as well. But other than that, Gunship itself does not define any systems that happen at runtime. Now, for the other question, you had asked me about P2. You had asked what optimizations I had performed on P2. So I wanted to go over those and kind of show specifically some of the things that I've been working on. For the creation destruction test that I've been running, the majority of the time was being spent with drawable. The test itself is being run if we open up creation destruction.cpp. What I'm doing is I'm creating cubes with this cube factory, and if we go to cube.h, cube inherits directly from drawable and terminable, because that was the only functionality I needed for this test. I just need to be able to place a cube in the scene, and then I need to be able to deregister from the scene when I was done with them. And so a lot of the time was being spent in drawable. The majority of the functionality here was when you enable. Let's see if we go to cube. Let's say cube.create recycle. Oh no, I bet it's in. Yeah, here we go. So register for automated. So the majority of the time was being spent somewhere in here. When I created the however many cubes every frame, register for drawing would go to the drawable manager and insert it, would append it to the end of the list of drawables so that all the cubes could be drawn every frame. And that was taking up a lot of time for a couple of reasons. If we find our drawable manager.cpp, when a drawable was being registered, it would do this check of is the drawable already registered? If not, then we don't need to do anything. But before this was happening, this was using a standard find on the list, which means it was iterating over the entire list to check and see if the drawable pointer was already in the list, which was, of course, incredibly inefficient. To fix this problem, I went to drawable and I added, if you scroll down to the bottom, I added this, this can be removed, that's actually old code. I added this bool to check if it's registered. So that I'm cut down, here we go, drawable manager. If we go to drawable manager, now we just directly check within the drawable if it's registered or not, and the same thing happens in deregister. We just check that registered flag, and that I think doubled the speed of the scene update in P2. So that was acting like a big bottleneck. The next thing that was happening was actually inserting into the list was incredibly slow. It was taking a huge amount of time just to append a node to the linked list, which I thought was crazy. So I took the same approach that I did in Gunship, and I went and started to do a custom data structure to speed things up. Um, and this is something that I did today. So these I'll show you the results of these changes in a second. But what I did is I made drawable itself an intrusive linked list. So now every drawable has a pointer to the previous drawable on the list and the next drawable on the list. And when drawable manager, when it's registered with the drawable manager, it's simply inserted into the list, and when it's deregistered, it's removed from the list. And then draw all was changed to iterate over the list and draw the entire list. And after I did this, if we take a look at the spreadsheet that I had before, I had this highest level test before of creating and destroying 10,000 or 1,000 cubes per frame with 10,000 cubes staying around to be rendered every frame. And before I converted drawables into a linked list, it was taking almost 300 milliseconds per frame to perform those insertions and removals. After I converted it to a linked list, that number dropped to 4 milliseconds per frame. So standard list was acting like a huge bottleneck. It wasn't actually giving constant times, insertions, and removals. With that fixed, the numbers for P2 wound up roughly matching the numbers for Gunship at this Gunship when I enabled object pooling in Gunship. But after that was done and I profiled it again, I found that I was running into the same problem with the terminable manager. Terminables were doing the same thing where it was using an STD list to track terminables. So I did the same thing with terminables. I converted it into an intrusive linked list, and I changed it to terminal manager.cpp. I had it manually insert it into the list. And that actually dropped the scene update time down to 1 millisecond for this highest level stress test. That's really good. That's like as good as I could possibly have hoped to get out of it, and I could probably find maybe a little bit more performance to squeeze out of P2, but at this point I didn't see any more major bottlenecks. So I'm pretty happy with that for the purposes of for this test. I'm probably going to start moving on to the next test. And just in relation to that, I wanted to talk about where I stand with Gunship currently. And let me quickly just run the test. So if we set the total cubes to like 100,000 and we do 1,000 cubes per frame in P2. This before would have taken like a minute per frame to run. If we run that and let it compile. Give it a second to go. We can see it takes 1.5 milliseconds to do the scene update. And this isn't running at like 60 frames per second because it takes forever to draw. The renderer isn't terribly optimized, but the scene update is now highly optimized. So that's good. That puts me at a good state for P2 for the any future benchmarks. In Gunship now, if we do, say, the same test, we do 100,000 total cubes, so some crazy number of cubes, and 1,000 cubes per frame. Let me run that. And this of course, taking so long to start up, that's a problem that I'll have to address, but I'm pretty sure the majority of that is bottlenecked by Ogre, which is something that I could fix at some point, but it'd require me to dig into my usage with Ogre and really like highly optimize the way Gunship uses Ogre, which is not something that I feel I need to spend a lot of time on. You can see here that Gunship at that high level of testing does not run as well as P2. However, when I look into where the bottleneck is for Gunship on this one, this number drops down ultimately to around like 2 milliseconds. The bottleneck, if we look inside Gunship, is actually with an Ogre. In the scene update, in the creation destruction manager, when I'm setting the position of the nodes when I create them, if we look up here, I set the position of the transforms when they're recycled to place them randomly in the scene. And if that winds up being a bottleneck. That's taking up like half of my scene update time, which is some problem within Ogre that is a bit out of my purview to address. But if I were to comment that out, maybe drop down the total number of cubes so that it doesn't take so long to render. Then we see that value drops down a whole lot. So I'll ask around on the Ogre forums if anybody's got any advice on how to optimize that, but for the time being, I think I'm pretty satisfied. Right now, Gunship's performing a little bit worse than P2, but it's due to extenuating circumstances, and I'm gonna have to deal with for the time being. I just want to see quickly how Gunship runs. There we go. Yeah, so when we're not moving the cubes around every frame, it runs much better, but that's not really an excuse that's going to work at runtime. You have to move things around in the scene. So that's about it for the creation destruction test. I'm going to start moving on to other tests in the next week. Hopefully that answers your questions. If you have any other questions, you can send me another email. All right, thanks.